Today we're looking at section 8.6, using factoring to make predictions with quadratic models. We have the number of U.S. households with VCRs are shown below for various years. What are VCRs? Do you guys even remember VCRs?
Video something.
Video cassette recorder. This is what we had before we had DVDs. We had these big rectangular tapes that we would push into a player, and they could record our TV shows for us, and you could buy a movie. VCR tapes. Now, how many people have VCRs in their home today? 2 or 3 maybe? I don't think I have one in my house anymore. Anyway, it gives us some data. And as you can see, the number of VCRs is certainly decreasing. Decreasing because DVD players started to take over. All right, so let n equal f of t be the number in millions of U.S. households with VCRs at t years since the year 2000. Use your calculator to draw a scattergram. All right, here's my calculator. Remind me how I use my calculator to draw a scattergram. Stat. Edit. Enter data. All right, so I gotta clear out the old stuff, right? So I'm going to go up, clear, enter. Clear, enter. Now I do need to be careful. What am I going to put into L1? What am I going to use for my x's?
The years since 2000.
Years since 2000. So I'm not going to type in 2005. Rather, I'm going to type in 5, 6, 7, 8, 9, and 10. And I move over. 98.9, 97.7, 95.2, 88.8, 82.5, and finally 74.3. I'm going to get rid of L3 as long as we're here. We don't need it. You even know what that is. Once I have my data typed in, how do I make my calculator draw me a pretty picture? Well, a good idea would be go to y equals.
Yeah, that's what I was going to say.
Clear out anything that you have typed in. Turns out I don't have anything typed in, so I'm okay. Then I need to tell it, draw that data. What's the key for draw that data?
Make sure plot one.
Make sure plot 1 is on. So I got to go to second stat plot, which is on the y equals button. Make sure it's turned on. And I need to change mine to be that one, because I had a histogram up there before. And I need L1 and L2, and I like the little boxes. Zoom, number 9, for zoom to fit my statistics. Looks like that. So then it asks, does the data appear to be linear or quadratic? Linear, that looks like a line to you? Kind of. It kind of looks like a line over here, I would agree. Those last 3 maybe look like a line. But it looks to me more like a curve, more like a parabola. Now, we haven't talked a lot about parabolas yet. We will in the very near future, like Wednesday. But I think this is more quadratic than linear. I think it's a curve, not a straight line. So I would say that looks quadratic. So to answer the first question, I would say it looks quadratic. And then it says, use your calculator to draw the graph of f of t equals minus t squared plus 10t plus 74. So they're giving you a model. And that's a quadratic equation. How do you recognize that that equation is quadratic? What makes equations quadratic? T squared in them. So I'm going to go to y equals, and I'm going to type that in, minus x squared. We have to use x, of course, in the calculator. Plus 10x plus 74. Does that quadratic equation that they gave us fit the data pretty well? Yeah, in fact, it looks like it fits it very well, doesn't it? Okay, so that looks like a good model. Does the model fit well? Yes, yes it does. What is the n Intercept. Okay, how do I find n-intercept again? T equals 0. To find the n-intercept, whatever the letter is, you make the other letter equal to 0. So if t equals 0, well, I think I can just plug into my formula here. I like this. When I plug into my formula, n is 74. So what does that mean? T is 0. When was t equal 0? In the year 2000, because we said t is years since 2000. So in the year 2000, what happened? There were 74 million houses with VCR. So in 2000, there were 74 million houses with VCRs. So as you can see, from the year 2000 to the year 2005, the number of VCRs was actually increasing. In 2000, there was only 74 million. By 2005, there was 98 million. So they were increasing for a while, and then, like I say, about this time, and somewhere in the early 2000s, DVDs started taking over. Okay, and then part D. Predict when only 18 million households will have VCRs. What are we going to do with part D? Set it equal to 18. Why set it equal to 18? How come we don't plug 18 in? 18 is the number of VCRs. It's not the time, is it? So I don't plug in for time. That's a common mistake that people make. I want minus t squared plus 10t plus 74 equals 18. I'm trying to find time. Predict when. Find the time. Okay, how would you solve that equation? Subtract 18. Okay. So minus t squared plus 10t plus, what's 74 minus 18? 56 equals 0. We noticed we had a quadratic equation. It had t squared on one side. So that told us in order to solve, we needed to have 0 on one side. Whenever you have a t squared, you've got to have 0 on one side. Now what? Now we want to factor. How do you factor that?
You can factor 4 and 14 to make 56 and 10.
Very good. Now what I would do, personally, I don't like factoring when there's a minus 1 in front. So I think what I would do before I try to factor, I would take this whole equation and I would multiply everything by negative 1. Just to make that first term positive. I like that first one to be positive. So I think I would write this as t squared minus 10t minus 56 equals 0. And then to me it's easier to factor. Easier to factor, for me anyway, when the first term is positive. All right, and so I heard a vote for t and t, and then a 14 and a 4. Which one's positive, which one's negative? Plus 4 minus 14. That does give me negative 10 in the middle, and would give me negative 56 on the end. I think I get two answers. T equals 14, t equals negative 4. Are both those answers okay? Okay, well, what would t equal 14 tell us? That would be the year 2014. So I think that answer is okay. How about t equals minus 4? Does that make sense in this problem? I think it does. It would just mean the year 1996. We started in 2000. This would simply mean 4 years before 2000. So in this case, I do think that number would make sense. It's one of those rare cases where I think time can actually be negative. Because we didn't start at time 0, we started at time 2000. I can talk about what happened 4 years before the year 2000.
So that means like in 1996, there was only 18 million, but it was increasing.
Correct. So what was happening in 1996, there was something that came before VCR, something called Betamax. Very few people remember Betamax anymore. You got to be pretty old to remember that. So in 1996, there was a popular thing called Betamax. And that one started to fade out in popularity. It wasn't as sturdy as VCRs. So that one started to fade out, and VCRs started to pick up. So from 1996 until somewhere around 2005, VCR started becoming more and more popular. Back in 1996, there were only 18 million households. By 2005, 9 years later, there was 98.9 million households with VCRs. And then, like I say, DVDs started to take over. So the number of VCRs started to decrease from there. Till the point, the year 2014, last year, apparently, there were only 18 million houses with VCRs. Questions on that problem? All right, let's try number 2. Number 2 says, the percentage of Americans who think labor unions in the U.S. will become stronger are shown in the table below for various years. There's the data. Let P equal F of T be the percentage of Americans at T years since 2000 who think unions in the U.S. will become stronger. A model of this situation is, and they give us an equation, use your graphing calculator to graph the data together with the model. All right, so very similar to what we did in the first problem. We have to go in, we have to type in our data, type in our equation. So stat, edit, clear out this old data, we're done with that. Type in the new data. And again, you got to read carefully, notice it's years since 2000. So again, I'm going to go 4, 5, 7, 9, 11. I don't type in the exact years. 4, 5, 7, 9, 11. Over here we have 21, 19, 19, 22, and 25. I'm going to go y equals, clear that out, and type in the equation they gave me. 1/4 x squared minus 3x plus 28. 28, I said, not 20 bracket, 28. All right, so I have my data typed in. I have my equation typed in. Zoom number 9, so that the calculator will give me a window that matches my data. And it looks like that. Does that equation fit that data well? It's decent. It's okay. It doesn't look as good as the last one did, but I think it's okay. It comes pretty close to most of the points. Not perfect. We never expect it to be perfect, but we expect it to be fairly close, and I would say that's fairly close. Not too bad. So yes. Period. What is the p-intercept? Again, to find the p-intercept, t needs to equal 0. I go to my equation when t equals 0. That's easy to figure out. P is 28. What does that mean? In 2000, 28% thought unions would get stronger. Questions on that? Part C. Predict the percentage of Americans in 2017 who think unions will be stronger. What am I doing in Part C? Plugging in 17. This time they are giving us a year, 2017. That's a t value. So t is 17. So I'm just going to take my calculator. 1/4 times 17 squared minus 3 times 17 plus 28. Calculator says 49.25%. So nearly half the population in the year 2017. Finally, Part D. Predict when 44% of Americans will think labor unions will become stronger. What am I going to do for Part D? Set it equal to 44. Once again, now they're giving us a P number. P is percent. We want to find T. So I'm going to have 1/4 T squared minus 3T plus 28 equals 44, and I need to solve that equation. Once again, I recognize this is a quadratic equation. What tells me it's quadratic? It's got an exponent. It's got in particular, it's got a T squared. That's quadratic. To solve a quadratic equation, we need 0 on one side. What would you do to get 0 on one side? Subtract the 44. 1/4 T squared minus 3T minus, what's 28 minus 44? Negative 16. Oops, I already got the negative. Equals 0. Now I need to factor. How would you factor that? I could. That's the hard way to do it, though.
Use the formula.
Which formula?
Minus b equal plus or minus square root.
Oh, we don't know that formula yet. The only thing we know is to factor. We'll get to that formula fairly soon, but we don't know that formula yet. How do you factor when you have fractions?
You can factor out 1/4
Even better than factoring out 1/4.
or 1/4.
What do we do anytime we see an equation and that equation has fractions? Multiply by the common denominator. Just like we did with that sheet of literal equations. Every one of them that had a fraction, we started by clearing the fractions. I'm going to take everything in this equation and I'm going to multiply it by 4. And I'm going to get rid of those fractions. I'm not going to deal with the fractions at all. When I multiply by 4, I get T squared minus 12T minus 64 equals 0. And now it's much, much easier to factor. I don't need fractions. I don't need to factor by grouping because now I've got a 1 out front here. Should be pretty simple. I have T and T. How can I get a negative 64 on the end and get a negative 12 in the middle? Positive 4 and negative 16. Positive 4 and negative 16 add up to negative 12. 4 times negative 16 is negative 64. I get two answers. T equals negative 4. T equals 16. Once again, I think both these answers are acceptable. We started in the year 2000. So T equals 4 would mean back in 1996. That's an interesting coincidence that we got 1996 for both problems. That was just happy luck. Nothing real about that. And our other answer would be 2016. Questions on that?